Hi everyone, I hope you're doing great. Imagine I tell you two facts. Harry is friends with Ron, and Ron is a brother of Ginny. Now let me ask you a question. How is Harry related to Ginny? The answer exists, but it is not written anywhere. This is where a traditional RAG system would break. A RAG system is good at finding answers that are present inside the document. But our answer is not present inside one document, it is spread across multiple documents. This is where GraphRAG comes into the picture. Imagine graph as a map. Entities are nothing but locations. Location A, location B, location C, location D, like that. And the relationships are nothing but roads. So when we're trying to find an answer, we are not trying to read it. We are trying to traverse these roads. Let us build the smallest GraphRAG possible. Before we start, I would like to show you the project structure. I have only created one Python file, main.py. By the way, I haven't used any frameworks. I haven't used Neo4j or LangChain. It is pure Python. We will start with our source data. In production systems, this could be multiple documents, PDFs. For the demo purpose, I have kept it just 2 sentences. I'm going to convert these documents into a graph. Harry becomes a node, Ginny becomes a node, and Ron becomes a node. And the relationships become the edges connecting them. After that, I've written a simple BFS function. Since I want to traverse my graph, here I am using BFS. You can use DFS as well. Let's try to understand what BFS is actually. So here I've taken a graph, as you can see. BFS uses a queue data structure. Why? Since you're traversing level by level and not by height, not by the height depth of the tree, you're gonna use a queue because queue works on first in first out basis. Since A is on top, I want A to be traversed first, then B and C, then D and E, and then if there are more nodes at the bottom, then so and so. That is the reason queue is used. Now, while my queue is not empty, the queue starts with A. Now I'm going to check if my queue is not empty. Yes, it is not empty. So I'm going to pop this out, mark it as visited, and then insert its children. Now again I'm going to check if my queue is empty or not. My queue is not empty. So again I'm going to pop this out, mark it as visited, insert its children. Similarly, C, mark it as visited, it does not have any children. Go to D, it does not have any children. Go mark it as visited, go to E, that's all. This is how BFS works. Now if you want to stop your BFS function, the moment you find in a particular node, you just have to write a check. If I would have wanted to stop the function when I find C, the path would be A, B, C. Now let's test it. How is Harry connected to Ginny? We call the function the BFS function. It finds the path between Harry and Ginny. Now we need to build a context from the retrieved path. Once we ask the question, we are going to get the path between our entities. Now, since our LLM does not understand anything but text, we need to convert the path which we retrieved into some context. So after this function is called, we have stored the path between Harry and Ginny inside our path variable, and then we are going to build the context using that path. So if you see this function, what I've done here is I've converted the path into a text. So that's all this function does. I have printed it, we can see it in the output as well. The retrieved path was this. Then after forming the context, this is what we are extracting from the path. Now we need to send our prompt to the LLM. Here I've used GPT-4 mini. You can use any LLM of any model of your choice. To be able to connect to this LLM, you need something called an API key. I have set the key in the environment variables, so you can do the same. Once we send the prompt, this is what the prompt would look like. I am strictly, by the way, RAG is the most useful when it comes to reducing hallucinations. So we are going to make use of that. So how that happens is that I strictly instruct my model not to give me an answer outside of the context that is provided to it. So now since I have asked this question, this is the context along with the question. So I give the question, I give the context, and I expect the model to use that context to answer the question. So as you can see, I am getting this output. Basically what it says is Harry is connected to Ginny through Ron, As Harry is Ron's friend and Ron is Ginny's brother. Just to have it real time, I would run the code. So as you can see, the output is this time. The way it gives the answers can vary, but the overall meaning of the answer will be the same. Thank you so much for watching. If you understand GraphRAG, if you have been following so far along, you're already ahead of most of the people because you have actually built something from scratch. In the upcoming videos we'll be focusing more on different types of patterns and code. So yeah, thank you so much for watching.